Hello, my name is Deborah Greaves. I'm Professor of Ocean Engineering at the University of Plymouth, and I'm leading the collaborative computational project on wave structure interactions, the CCP-WSI. I'd like to give a warm welcome to everybody for joining our kick-off meeting for the CCP-WSI+, and also to help us with our focus group workshop in which we want to start to prioritise the research challenges in wave structure interaction for this CCP. I'd like to start today by giving you an introduction to the CCP-WSI+ and a little bit of background on what we've been doing so far over the last 5 years within the CCP-WSI. So our collaborative computational project in wave structure interaction started in 2015. It was funded for 5 years by EPSRC. And we started off with a group of 5 academic institutions: University of Plymouth, Exeter, Manchester Metropolitan University, University of Bath, City University, and also STFC. And we were supported by 34 project partners, which included industry and academics, both in the UK and internationally. And our aim was to develop and maintain a robust and efficient computational WSI modelling tool, to build and grow the community of researchers, data and code and expertise around wave structure interaction, and to provide a framework for innovation and development of strategic software. So those are the aims. We ran a number of activities and led developments to help towards achieving those aims. We set up the CCP-WSI code repository, which is hosted on the GitHub and hosted on our website, which you can find at the web address here. We have a data repository with benchmark data, experimental and numerical modelling data available for anyone to use, to download and use. We run a number of activities, repository workshops and training events in order to show people how the repository works and encourage people to use it, to access the code that's available there, and also to contribute and develop their own code and share it through our repository as well. We run a series of code developers workshops when there's an opportunity for us to and the community to show the code developments that they've been making and to share those more widely. We also ran a residential hackathon event, which was an intense week of coding and working together on some specific coding challenges around CCP-WSI. Then we have also run a number of focus group workshops like the one today and industrial engagement events when we share developments and also work together to discuss and to identify the research challenges that they are, the new applications and challenges that we'd like WSI code to tackle, and what's needed in order to do that, and how we might prioritise that and think about the timescale of those developments. And then we've also run a series of blind test workshops in which we have shared a setup for an experiment, and then we've invited people from anywhere all over the place to take part in the test and to simulate the test case using their own codes. And I'll say a little bit more about those later on. So what are we planning to do in the new CCP-WSI, which is our WSI+? Well, we're extending this. We're very pleased to have been funded for another 5-year duration, starting from the 1st of October this year. So a further 5 years, and we've also, as well as that funding to carry on to continue these developments, we also have support from COSEC to help us with this. And Stephen and the rest of the team are here today and they'll be able to tell us a little bit more about what it is that they're doing to support this, this code development. So the proposers, the working group, the PI and co-Is, has been expanded from 5 to 8 academic institutions, still led by the University of Plymouth, joined by the University of Glasgow, Newcastle University and Manchester University. And we've expanded our aims within CCP-WSI+ to bring together the 2 communities of computational fluid dynamics, the community which were involved in the initial CCP, WSI, but also to invite and get more people involved from the computational structural mechanics community. Some of the problems we're working on now need full coupling between the fluid and the structure, and we really need to bring together the communities for CFD and CSM. So our proposal this time was supported by 62 project partners. So we want to build on the impact generated by the CCP-WSI, the first 5 years of the project, and extend it, as I said, to connect together the computational fluid dynamics and computational structural mechanics communities. We're expanding the website and increasing networking and industry workshops. And the aim of these is to share good practice and to exchange advances across the disciplines. Then we want to support and accelerate the development of the new code, its utilisation and implementation, and also closely work together with experimental fluid and structural mechanics as well as computational fluid and structural mechanics. So we want to develop fully coupled wave structure interaction modelling tools. We will maintain and expand the CCP-WSI code repository and the data repository with further enhancement of the database there of test cases and benchmarks, and also enhanced visualization and archiving. We're planning a series of training and workshops to support the community code development and to support co-creation of code coupling methodologies and libraries in an open source environment. So again, we want to encourage the community to work with us, to work together in this open source environment, to make use of the code repository and also to contribute to the code repository. We're planning to extend our blind test series. This was a very successful part of CCP-WSI. In order to prepare for the new high performance computing architectures, then we are planning parallel optimization work to support optimization and implementation. One of the key elements of this is coupling between the computational fluid dynamics and the computational structural mechanics, and also coupling within each of those as well. So coupling and parallel optimization are key parts of the focus of the work. And in order to focus the work into strategic software development and code rationalization, we're running a series of road mapping exercises, and that we're going to start with the first one of those today through our industry workshop in starting to collate together a list of challenges in wave structure interaction coding, and also to run a software audit on the codes that are available at the moment. So this is the team. This is the core team of universities involved in delivering the CCP-WSI+. So we are the working group, and we're joined by 60 or so project partners. So I just want to go into a little bit more detail now about each of the different elements that we're developing. First of all, the CCP-WSI website. You can find this at the web address here. You'll find announcements and news items reported there. There's a contact page, you're able to join the mailing list and to sign up to get access to the code repository. The About page tells you all about who's involved and what's going on. Working group members, project partners, link projects, and so on. There's an events page to keep up to date with what's coming up. Of course, we'll also circulate information on events through the mailing list. We have a publications page where we'd like to publicise and promote the publications coming out through CCP-WSI, the code repository and the data repository. I'll talk about it in a little bit more detail. And then we also have the latest stats there that tells you a little bit about number of publications and visits to the repository and membership and so on. So the data repository, which can be found at this web address. So go to the website and then click through to the data repository. Here we are storing a series of sets of data for different test cases. So these data can be physical experiment data or numerical data, or even theoretical data, and they form a set of test cases that might be very useful for benchmarking codes and for testing codes as you make changes to them. There's a sort and search function on the website, so you can easily identify the test case, the type of category, the type of test case that you're looking for. And each one is populated with a full set of details and description of the setup. So it should be relatively straightforward to take that test case and set it up with your own code or in your own environment. And the data is available publicly to download. We'd like to add to the list of benchmark tests we have on the data repository so far. We'd like to increase these. Obviously, up to now, they're mostly wave structure interaction. We'd like to increase this with some traditional structural mechanics cases and also some fully coupled cases as well. So we plan to expand and enhance this, and also to have some database visualization and archiving, as well as a community upload function. Then if we move on to the code repository, so this is where we'd like the code to be developed in this open source environment. This is hosted on GitHub. The website is here. And again, it's via the CCP-WSI organization. It's a private repository, but there are no restrictions or joining requirements. You just need to complete the form with your contact details through this contact web page, and then you'll be given access to the code repository. Instructions and guidance are set out in full, with also instructions on how to contribute code and how to use the code that's available there. And that's all on the GitHub wiki. So we'd like to enhance and extend these code developments. We'd like to encourage more people from the community to take part, to use the repository, and to upload their code. And we will be continuing to run a series of workshops and training courses on the code repository on how to use it. We're planning to have periodic code releases of the code as it's developed, headlining developments, and official recognition and authorship granted to developers. We're planning a number of networking activities over the next 5 years. We're going to have a series of workshops and other activities. First of all, repository workshops and WSI training events. These will be training in use of the CCP-WSI code repository and in software engineering and other aspects of code development and the work that we'll be doing over the next 5 years. Then we have our code developers workshops, and these are an opportunity for us to share developments with the community, to share and discuss and disseminate the work that each of us have been doing, and there'll be invited presentations at those. Then we have hackathons. We're planning another 2 hackathons following on from the very successful one organised by Ed last year. This is a residential event, focused, intensive week or few days of coding, a number of people working together on code development of a specific area. We also have our focus group workshop and webinars, the first of which is today, this afternoon. When we engage with industry, we talk together about the challenges in code development for WSI, the new applications that it's needed for, and have a discussion to think about what are the priorities and to help us with road mapping so that we can publicise that and share that with the rest of the community. We have blind test workshops. I'll say a little bit more about our blind tests later on. But these are used really to assess WSI codes and to help inform future WSI modelling standards and best practice through a series of blind tests when we can share some code setup for a simulation, invite people to simulate the test case using different types of code, and then share the results together and discuss what that means. We also have funding to run some pilot projects and industrial secondments. And we also have outreach activities. So we'd want to get to promote and get information out there to different audiences about what we're doing within CCP-WSI, and to get people enthused and getting involved in wave structure interaction. I'd like to say a bit more about the blind test workshops. This is where we share the setup for a test case and invite participants to take part and to simulate that test case blind without seeing the results, and then we share the results and compare and contrast. So the participants won't see the physical results prior to submission of their results, and the aim is to bring together numerical modelers across the community to assess the numerical codes currently in use and to better understand the required level of model fidelity needed in different types of wave structure interaction simulations. And this will help us to inform the development of future code and also numerical modelling standards. So we've run 3 series so far within the CCP-WSI. The first one was brought together, and the results were shared through through a few sessions at the ISOP conference in 2018. These are all experiments that have been run in the ocean basin at the Coast Lab in the University of Plymouth. In the first case, it was a fixed FPSO in focused waves. An FPSO is a floating production, storage and offloading large offshore structure used in oil and gas. In this test series, we had this device fixed in the ocean basin and interacting with focused waves, a series of focused waves. 34 participants took part. So we had 10 submissions. They were all presented at the ISOP conference, and then 5 of those were published as journal papers. The second 2 series, first one was shared at UTEC, that's the European Wave and Tidal Energy Conference in 2019, and the next one was ISOP in 2019. And each of these involved floating structures in focused waves. One floating structure, which was a cylinder with a hemispherical bottom, and then the second one was a cylinder with a hole in the centre, so like a moon pool. And the idea is that each of these are have increasing complexity, so going from the fixed structure in waves to a floating structure which is moored. In one case, it's a solid structure. In the second case, it has a moon pool. And the cases in series 2 and 3 both had focused waves interacting with the floating device and focused waves of different steepness. So we had 11 submissions to series 2 and 10 papers, journal papers, have then been published in a special issue of the ICE journal Engineering and Computational Mechanics. And then series 3, we had 10 submissions and 9 papers have then gone on to be published in the journal for offshore and polar engineering. And here are some examples of the results, which show the spread of the results and the codes that were participating in this particular blind test. So you can see that we can do some really interesting comparisons between the different codes. General conclusions that have come out of these studies so far show that the studies need a careful planning to coordinate them well in order to get useful results from the data. We need very well defined test cases, because the first thing is to make sure that everyone is reproducing the same test case, and it seemed very important that we made sure that we had wave only comparison first to make sure that people could calibrate their codes correctly. Considerable scatter we found in the solutions, even between similar models. This shows really the importance of the user and the expertise of the user and the variability in application of these codes. To find a distinction between the numerical models of different fidelity, to really sort of separate the models in terms of their capability, it's important to design the test cases span a step change in physical phenomena. So, for example, to go from quite moderate waves to steep waves, and to go from steep waves to waves which might involve some overtopping and splashing, maybe in order to separate out the capabilities of different types of code. We also found that quantifying the predictive capability is not trivial, and surrogate models or lower fidelity models, which can be informed by higher fidelity methods, may be the best compromise between accuracy and speed. But really we need to fit the tool, the numerical tool that we're using and the numerical method we're using to the application and make sure it's the right tool for the job. Okay, so that gives you a brief overview of the CCP-WSI+ and what we're aiming to do and what we'd like you to work with us on over the next 5 years. Now I'm going to hand over to, well, it's time for a few questions if anyone's got any questions. And otherwise, I'm going to hand over to Dr. Stephen Longshaw, who's going to tell us a little bit about the COSEC support and what COSEC will be doing, contributing within their work packages. We'll then have a short break. And then we're going to have a short presentation from each of the working group participants, the core group within the CCP-WSI+, who are going to tell us a little bit about the activities within each of their institutions and what they aim to contribute and to get out from the CCP-WSI+ over the next 5 years. We're then going to have quite an extended lunch break before going into the afternoon session. Thank you very much. I'm happy to take any questions.